Okay, so like Glenn mentioned, today we're talking about delegation, which is actually not necessarily specific to Objective-C. Delegation is what's called a design pattern. It's a really common design pattern across languages and across development platforms that enables a lot of really powerful behavior. So once my clicker wakes up. Okay, so the term delegation, who's heard of the English word delegation? So in English, the word to delegate is to basically to ask somebody else to do something on your behalf. Managers are often said to delegate their tasks down to their employees, and that's a similar concept that logically we've borrowed that concept for programming use. And as Apple's core competencies document, which is a really great document, it defines basically all these really common definitions of words that you might be unsure about, that you've heard talk about, things like delegation, things like view controllers, things like views. Really just gives some basic definitions of all these things. It's a great document. But just like with people, delegating a task onto another person, delegation is a pattern in which one object acts on behalf of another object, or in coordination with another object. And so an object that defines a delegate will ask some other object to perform some behavior that it wants, rather than implementing it itself. Okay, so a slightly more formal definition. This is again taken directly from the Apple's documentations. The idea is that there are two objects in question when we're dealing with delegation. There's the delegating object and the delegate, the delegated object. The delegating object keeps a reference to the delegate object, and at times where it is appropriate, it sends messages to its delegate object, and those messages may give some sort of response back to the delegating object, so that way it can gain some information about what's going on with the delegate object. Generally speaking, a delegation pattern allows some object to be notified when events are happening to some other object. So a delegate might be interested in when we'll see some more concrete examples later, but you might have an object that you're making a web request, and you're interested in getting notified when that web request comes back, because those often take a long time relative to computation cycles. So the URL connection will define a delegate, so that way you just listen for incoming messages as things happen to processing that URL request. Okay, so again, this is from Apple. They say that the delegate object may then respond to that message by updating the appearance of the UI or its state or other objects in the application. And if the delegating object wants information back, that delegate method can then return a value as well. So an example delegation pattern is a window. So windows obviously are very common on macOS applications. Every application has a window. And for things like being able to close the window or zoom the window or minimize the window, rather than having every window of every application subclass window to customize the behavior of closing or resizing or minimizing, because it's way unnecessary to subclass NS window, when really all you want to do is just customize the behavior of close or zoom or minimize. NS window defines a protocol, just a set of methods. That's called the NS window delegate is the protocol name, but it just specifies a bunch of methods, and some object can then be assigned as the delegate for the window. So that way, when events happen to the window, like the user presses the close button or the user presses the minimize button, it calls a method on the delegate object. So that way, for example, if your application has saved data that has changes that haven't been saved, and you don't want the user to quit without saving the changes. If you weren't able to hook into the window being closed, the window would just be closed and the user would lose their changes. So you can define one of the methods in that delegate protocol for a window is window should close. And that asks the delegate object, hey, user pressed the close button. Do you want to actually close the window? And if you do, then you can just return yes. If you want to alert the user that that you have unsaved changes, for example, you can return no in that case, and then it will say, okay, actually, then Coco will be okay, I'll back off, I won't close the window yet. I'll let you do whatever you want to do first. Does that sort of make sense? It's kind of how, as one example of delegation. We'll go through a bunch of examples today, And you'll have a really great hands-on lab on Tuesday after we've talked about view controllers to really get some The best way to learn delegation is to do it by practice. So as you can see, delegation is actually a really very simple idea. It's just, here's another object, and then you're going to call other objects, methods on that object for information that you want. But it allows you to do things, some pretty powerful customization. And again, it eliminates, in a lot of cases, the need for subclassing. It's such a powerful tool that Cocoa and Cocoa Touch use it all over the place. Doing a search through the documentation, found over 100 different protocols that were named something delegate. Most of them belong to AppKit or UIKit, which are the user interface facing elements of the framework classes, and it allows you to customize the behavior of these built-in objects without really needing to subclass them all the time, which is really quite useful. So like I said, it's best done by example, so let's work through some examples. The one you've probably seen already is NS Application Delegate. So this is the delegate for your application. Remember we talked about Mac OS, when your application launch, creates an instance of NS Application, and then sets a stock project will come up with one class called usually your project name app delegate, and it will set that class to be the application delegate for your instance of your application running. And so as events happen to your application's lifecycle, you'll get methods called on that app delegate. So the first one that usually gets called is application did finish launching. And so that gets called, as you might guess, when the application is finished loading and ready to go. It lets the delegate know, okay, the application's ready and running. If you have any additional customization or initialization stuff that you need to do, here's a great place to do it because you're already you're up and running. So this will get called once the main run loop has been created, but before it receives any events. So that's kind of useful if you want to do something after an event has been processed. You can't do it here yet because this will get called before any events come in. NS notification is just this really simple class that kind of just wraps up. There's a lot of different notifications that can be sent based on. There's like a launching notification. There's a quit notification. There's a hid notification. There's a minimize notification. And so that class just kind of wraps up which notification is being passed to these different event handlers. Kind of on the opposite end of did finish launching, there is application should terminate, which takes in the sending application and returns a response code that's do you want to terminate right now or not, basically. And so this gets called after the user selects the quit menu item, so either Command Q or actually going file quit, or no, application name quit. And generally speaking, when the user hits Command Q, you want to quit right away. It's unintuitive behavior, generally speaking. If every time the user tries to quit, it doesn't actually quit, and if for no other reason than that gets annoying after a while. But you in addition to being able to just terminate immediately, which is the default behavior, you can also cancel termination entirely, or delay it for a certain period of time. And the documentation explains really how to delay that behavior, or how to cancel the termination. And it's done basically by just returning a different response code from this method. So there's also application will terminate, which is this gets called once you're actually going to terminate. So once you get this call, you're going to terminate. You have no choice. The application is going to quit. So this is useful for doing last-minute cleanup. If you've allocated a bunch of memory or you have a bunch of file pointers open, this is where you want to close them down before you quit, so that way you've cleaned up your memory and done all that good stuff, just to kind of exit more cleanly from the system. Some other useful ones are will become active, did become active, will resign active, did resign active. So on OS X, there's one application that has active, or the applications have active or inactive status. The one that's currently frontmost is always going to be active. Once you are no longer the frontmost application, you may become inactive as OS X swaps out your CPU time. So these get called before and after becoming active and unactive. So that way you can, if you are inactive, you can throttle down animation speed. You can terminate timers and that sort of thing. So those are useful for that. There's also methods for when the application gets hidden or unhidden. So all OS X applications have an option command hide or application name hide that just makes the application disappear. So it's hidden from the screen for the user. So these get called before and after being hidden or unhidden. And so again, you can use these to terminate, to slow down or stop animations, so that way you're not wasting CPU time while the user is not looking at your application. Another kind of cool one is there's a method, application dock menu. So OSX applications, I'll just show you this. In your dock, if you right-click them, then you'll get a little pop-up menu. Some applications allow you to have additional custom behavior while you're running. So Xcode, for example, doesn't have anything special. What's a good one that has something special while it's open? So like Safari, there's a custom one here for creating a new window on the fly from the dock menu. So this method here allows you to specify a series of menu items for that menu in the dock. That can also be set in Interface Builder, but if you want to do it dynamically, you can do it through this. You can do it through this application delegate method as well. Okay, and then there's ones for opening a file or opening a new file. So these do the obvious things. When the user hits Command O or Command N, it says, okay, the user is asking for a file. Go ahead and open it. Set up your view or your window, whatever you need to do to actually open the file. And then you can pass a return value of yes or no based on whether or not you actually successfully opened the file. Okay, so here I have a really short demo of using NS Application Delegate. So I'm writing a very, very simple RSS reader that's going to prompt up a little window for asking me for an RSS feed name, and then will show me the most recent feeds from that RSS feed. So if I just run it right now, it launches. I don't get any windows. I can open a feed and I can get this window. So I was thinking, it'd be nice if this window immediately appeared as soon as I launched the application. So we can take care of that by going to our app delegate, and inside of application did finish launching, we can tell the window to make key and order front. So make key just says become the key window. That's the application. That's the window that keyboard events get sent to. So that's the main window of your application is the key window. And order front says bring it to the front of the screen. Okay, so now when I run, as soon as I launch, the window appears. So that's nice. Okay. Oh, that's not it. So right now, if I actually run this, I get a window with nothing because I haven't actually made the URL request or parsed any of the XML documents. We'll get to that because those are more delegate methods. Okay, another useful delegate pattern is NS window delegate. So I mentioned this earlier. So one really useful thing about, I'll get to it in a second. So a delegate for a window can listen to resize events. So as the user resizes the window by dragging any of the edges, now with line or the corner, the bottom right corner pre-line, or I think with zooming too. I think if you hit the auto zoom button, you get this called as well. But this will get called every time the user changes the size of the window. So it allows you to, if you need to, programmatically rearrange your views in order to make them fit in the new size of the window. One really neat thing is that the window will resize method, the one that's gonna this gets called every time the user proposes a change to the window to the resizing of the window. One neat thing is that it returns an NS size. So if you don't like the size that the user picked, you can return one that you like instead. So this is really useful if you want to enforce, say, a minimum size on your window, so that if the user tries to resize something smaller than that, you can just say, no, actually, I'm just going to keep it at the minimum size. And then when it actually does the resizing, it will just fit to whatever you return out. Really, really useful. And then there's window did resize, which gets called after the window has actually been resized. And so obviously window will resize gets called first. You can change it if you want, and then it will call window did resize. I can't remember if you guys have seen this already, but NS size is just a very simple C structure that contains a width and a height. Okay, there's also methods for when the window is minimized or unminimized, which in the delegate methods they call them miniaturization. I don't know quite why. But so there's will minimize, will miniaturize, did miniaturize, and did deminiaturize. So these get called as you minimize and deminimize the window. So if you want to, again, if you want to slow your application down, don't want to have any, you don't really need any animations while you're minimized, you can throttle those down and turn them back on as these methods get called. With Lion now, we have some additional ones for handling full screen. Since Lion has really great support for making your applications go into full screen, so there's will enter, will exit, and did exit full screen. So as you can guess, these get activated these get called as you activate and deactivate full screen mode. So these allow you to rearrange your views as necessary to actually take advantage of being in full screen mode. If you want to listen to repositioning of the window, there's window will move, did move, and change screen. So will move gets called as the user drags the window around by dragging the menu bar. Did move is after the window actually has been moved. And then window did change screen, so if your user has multiple desktops or multiple monitors, if the window switches between monitors, you can listen for that, and then you can resize it based on the new window, the new screen size if you want. And then the ones I mentioned earlier, so there's window should close and window will close. So again, window should close will get called right after the user presses the close button, and it allows them to, if you don't want the window to quit to close right there, you can return no and say, actually, don't close right now. The user needs to do something before they close. And then there's window will close that gets called after the window actually is closed. One thing to watch out for is that window, if the user quits, it doesn't call close all the windows. It just quits. So if you are expecting that, then you should also check for that as well. It's different behavior. It's only when the user explicitly attempts to close a window, either by clicking on the red button in the top left, or by hitting Command W, or going to the menu option. Okay, so let's see that. Okay, so we'll open up that feed again. And for no particularly good reason, I am going to show you give you some sample code basically of how to handle, suppose that this application isn't an RSS feed and it has some state that we're writing a word processor and they're editing, and we don't want to close the window if they have changes. So we're going to hook into window should close, so that way when the user hits close, we'll prompt them, hey, you have changes, do you actually want to close? So I'll give you some code for that. So we'll go into the controller for that window. Don't worry about that. We'll talk about that on next week. Okay, so you'll see that I've specified that this class fulfills the NS window delegate protocol. And so, actually, if we go into our nib real fast, and we look at the window, and we check this connection, so we can see that it's got a delegate object specified, and that is our file's owner, which in this case is going to be this controller object. So we specified that this object is the delegate for our window, and so we say that we implement the protocol, and then we provide a body for the method window should close. And so I'll uncomment this. And so what I did for just as an example of something you can do when the user presses close. So again, if you assume you have saved data that you don't want the user to quit without, I just made a little alert that just warns the user, hey, you have changes. Are you sure you want to quit? And so here's a little alert, and then I attach that alert to the window. And what's kind of cool here is that this alert also has a delegate protocol, and so it calls this method alert_did_end return code context info when the user presses one of the buttons. So I'm gonna basically just test if the return code is the what is that? That's the other return is going to be the don't save button. Okay, so now if we run this. Oh no, sorry, that's not a delegate. Sorry, I misspoke. That's not actually a delegate protocol. I specified the selector here. So the alert will invoke this selector when the user presses one of the buttons in the alert. Okay, so if we open this now if we try to close, we'll get this alert, and then if the user hits the save button, then we would actually, if we were doing this for real, we'd open up a save dialog so that way they could actually save their document. If they cancel, then it won't do anything. And then if we say, no, actually, I'm going to discard my changes, then we can actually commit to closing the window. Does that make sense? Any questions about this little setup just for a real quick? So again, the real delegation here is that this window should close gets called when we're pressing the close button. And so we can return no, saying, actually, I don't want to close right now. But you can imagine that the code here is arbitrarily complicated, so you do something like you test if you have changes, and only then do you say no. Otherwise, you just say, okay, go ahead and quit, or close the window. Okay, so another delegate protocol that's really, really useful in any application that talks to the internet is NSURL connection delegate. But before I talk about that, I'm going to motivate what we need this for in the first place. So increasingly, apps are getting a lot of their data from the web, and this is often done using just a real simple HTTP request. So you have the Twitter API, and you make a request to the Twitter API, and you get back some sort of response to their API. And relatively speaking, these requests are slow, at least compared with computation time. These requests are in the millisecond range instead of the nanosecond range. And so it's considered bad style if your application is blocking the main thread while it's making one of these requests. So these requests, they can take a very long time, and if you just do these requests in a synchronous manner, then you're just sitting there waiting for this method to end, which could potentially take a long number of seconds. And as long as that method is running, then the user can't interact with your application, and that's bad. So the recommendation is that you basically make these requests on a second thread, let it go kind of run in the background, so that way your application is still at least awake and running. So like I said, if your UI is not responsive while anything's going on, then that's bad, because the user doesn't know why their clicks aren't working, doesn't know why their touches aren't working. So you want to stay as responsive as possible and keep the main thread as fast as possible, and anything that takes any amount of extra time should be done on the second thread. So the solution to this problem is, rather than making these requests synchronous, in that you have to wait for the method call to exit before you actually have all the data, is to say what they call making them asynchronous. And the idea of an asynchronous request is you make a method call that starts a request, and it goes off and runs, and then that call immediately exits, and you can continue on running, and then sometime later you'll get that data back, and that's done through a delegate protocol. So you create an NSURL connection object and pass it a request. Usually it's an NSURL request, which just wraps up a simple HTTP URL request. Then, once you've fired off this request, it can run on the background thread. The cool thing is you don't actually have to worry about creating the thread. It's all done. It's all managed for you. And then once it's got data, it sends its delegate. Once anything interesting happens to that URL connection, it sends messages to its delegate. So the first interesting one is did receive response. So as the documentation puts it, this is called when the connection has received enough data to actually realize that there is an actual HTTP URL response. There's also did receive data. So this gets called every time the request receives some amount of data. This is not necessarily all done all at once. So if you have a very large document that's coming back from the web, in the megabyte range, you might get multiple calls of did receive data. And so it's the delegate's responsibility to piece all those together. You are guaranteed that they'll be in order, but they may not be all at once. So you have to, in order to actually have the entire response, the delegate object has to keep tacking on all this data into one big glob of data, and then once they have all of them, then they can actually use it. There's also did finish loading, which gets called after the URL connection is done and has successfully finished all of its connection. And then there's did fail with error, which, as you might guess, gets called if there's any sort of error in reading that connection. And then it's guaranteed that exactly one of these will be called, and after which no more messages will be called. So there's sort of a contract in the definition of NSURL connection delegate that specifies the order and number of these calls. Okay, so let's actually implement URL connection delegate so that we can grab that that RSS response from Apple's from our RSS feed. So the way I did that, how did I do that? Okay, so when the window gets loaded, it calls this set feed URL, which specifies what the URL of the feed we're interested in is. So the first thing I'm going to do is I'm going to create a URL request. So just a simple HTTP request that's with a particular URL in mind. And then I'm going to create a URL connection with that request, and then specify that self is the delegate for that request or that connection. So again, we can see if we go back to the header, we see that I'm implementing the connection delegate protocol. And then okay, so I put a little bit of error checking in here. So there's this if connection test. So if for some reason this connection just immediately can't reach the internet at all, it will come back as nil, and then you can push out an error message or something to say that the connection failed, it couldn't reach the internet. Otherwise, what I want to do is now I want to set up my data to have just some empty data in it. I'm using mutable data rather than just a regular data, because mutable data allows you to keep tacking on more, because I'm potentially going to receive numerous did receive data messages, so I want to be able to just tack all those onto one big glob of data, and then once I have them all, then I can actually do something with that data. So now if we look at the URL connection delegate methods, so we have did receive response, which typically you only get one, but if you are going through a page with a lot of redirects, you might get multiple, and so every time Apple's recommendation is you want to clear your data every time you get one of these, just because you don't want to stack together data from multiple different web pages. So that's easy. I can just reset the data to be nothing. Now, every time I receive data, I just tack that data onto my result data just by appending it. And then, if for whatever reason I get some sort of error, then I clean up my memory and show the error. Pretty simple. And then once it did finish loading, we are going to do something with it. For now, I'm just going to turn it into a string and print it out so that we can see what we're getting back from this feed request. So I'm going to make a string. Init with data. So I'm going to give it my result data, and it's going to be UTF-8 formatted. Okay, so now I'm going to just log that string out. Alright, so now when I run, we make this web request, and we get this great big long XML document, because that's how RSS is formatted, is as a real simple XML format. And so it's wrapped up in this string. Okay, so now we have XML, which is great, but how do we do anything with XML? Well, surprise, surprise, there is a delegate protocol for that. Apple has provided a really great XML parser called NSXML parser, and it has a delegate, and it's, actually, I'm going to stop first. So I'm going to motivate that in a second. So like I said, it has XML parser, which is a really great class for parsing XML documents in a very general way. It operates in what Apple terms an event-driven manner. So you might think that one way to build up an XML document is just you read in the entire document and then build up this great big hierarchical tree of everything that's in the document. But potentially, if you have a really, really large document, then you're going to take up a lot of memory building up this great big tree of everything that's in this XML document. So the default the way NSXML parser works is it does not do that, and rather instead, every time it encounters some interesting part of the XML document, it messages a delegate. So when it sees an opening tag, it sends a message to the delegate. When it sees a closing tag, it sends a message to its delegate. When it sees a bunch of text in between tags, it sends a message to its delegate. So that way, the XML parser doesn't really care what you do with the data. It just says, okay, here's something that happened to our. I found something in my XML document. Go ahead and do something with it. So then, whoever is the delegate for the parser can then, if they want to build up the entire tree, they can, because they have all these requests coming in of everything. They see a start tag, they see a close tag, and you can use that to build up the entire XML tree. And so the methods on parser delegate, there's did start and did end the document, which are called at the obvious times. When you receive a starting tag, there's parser did start element, namespace URI, qualified name, and attributes. So obviously it takes in the element that we found. So if we found an opening string tag, then it says that we have a string tag. I can never remember what namespace URIs are. It's some formattings, but I don't know XML well enough to know what these are. Namespace URIs and qualified names, but it's some formatting thing in XML as far as I'm aware, just to kind of specify the namespaces, I think. And then if that opening tag has any additional attributes, any values associated inside of the tag, those get passed in as a dictionary of attributes in key value pairs. Similarly, there's did end element, which gets called when you find a closing tag for a particular element. And again, we see the name of the element and the namespace information if you have it. And then there's parser found characters, which gets called when you just find regular ordinary string characters, usually in between tags. It's a greedy call, so it will find as many characters as possible until it gets some other thing. So usually, generally speaking, you'll get everything between two tags. I think if there's a new line, it stops at a new line. I'm not 100% certain about that though. But generally speaking, it will find as many characters in a row as it can before it would find some other event. So let's parse that XML. Okay, so rather than building up this string, I'm gonna allocate and initialize an XML parser with that data, and then now I can safely release the connection in the data because the parser has taken care of the data. Then I set myself as the delegate for the parser and tell the delegates to start parsing, and so it will run off and start parsing the XML and call all those XML parser delegate methods on this object as it hits different parts of the XML document. So I wrote a really general XML parser delegate for this that basically it actually builds up the entire tree. I'm not really going to go into the details of how it works because if you're not familiar with XML, it's going to seem kind of complicated. It's really not though. But the idea is I'm going to populate this RSS entries array with each entry from the RSS feed. And so I just check for the different elements. So if it's an item, then that's actually then I have an item, and then I have a dictionary that I'm currently populating with data for that current RSS item. And then as I find elements, I just populate that dictionary with different data as I need it. Again, I'm not going to go into the details. You can look at this afterward if you want. It's going to be on the site. And so when I find a closing tag, I add the entry to my array, and then I have a table view. We haven't really talked about table views yet. We'll talk about them later, but I just need to tell it it's all filled up in this table, and it has a way to grab the data from me, and then I just tell it to go. The table view, in case you're curious, is itself a delegate protocol. We'll talk about, like I said, we'll talk about tables more later. Okay, so now if I open up that feed, now I have this nice table filled with all of the titles of the articles, the links to the article, the description, and then the publication date. So this can, I did this in a general enough way that it works for pretty much any correctly formatted RSS feed. So any questions about this app? I'll put the source on the site so you guys can take a look at it if you want. So again, if I try to close, I get that. Okay, so that's really all I have. Again, I found that delegation is easiest to learn if you just do it. So you'll have a really great lab that gives you lots of hands-on practice with doing delegation on Tuesday after we've talked a little bit about view controllers. But the idea is, delegation, as we saw, is a very simple idea, but it's really quite powerful, and it's as a design pattern that allows you to, in most cases, eliminate the need for subclassing, so that way you can just add certain behavior that some other object is interested in. The other really cool thing about it is, notice that I had one object that fulfilled all of these different delegate methods. If I were to try to do this with subclassing, I would have needed 5 different objects, one for each of these different delegate protocols. But since it's just a list of methods that anybody can fulfill, I can put all this in one place and have a single source of truth. So that way I don't have to worry about keeping multiple objects in sync just to customize the behavior of all these subclasses of a window or a subclass of a connection or all these different things. So it's really quite useful for that. Okay, any questions? Okay, so there's no new lab today. We'll have it, the lab that corresponds to this, again, we need to talk a little bit about view controllers, so we'll have that on Tuesday.
I put up on the homework link, I put some links for setting up the unit testing under Xcode 3. Unfortunately, it seems like half the computers here have got the old Xcode 3 unit testing setup documentation and the other half don't, for some really odd reason. So there's some links that are available there. They go kind of in order of helpfulness. They're still a little bit dated, so I apologize. If you're having trouble setting it up, let me know.